Matrix multiplication notes the first major distinction or difference from the algebra of just numbers. One of the strongest differences is that the product of two matrices is not always defined, and that two matrices A times B does not always equal B times A. So in this case, matrix multiplication, the order does matter. The multiplication between matrices A and B is only defined if the number of columns of A equals the number of rows of B. In general, a matrix A times a matrix B, if A has dimensions m by n and B has dimensions p by q, will be defined if n equals p and will have dimensions m by q. So though we haven't even talked about how to calculate matrix multiplication, we can now say that a 3 by 2 matrix multiplied by a 2 by 5 matrix will have the dimensions, or will result in a matrix with the dimensions 3 by 5. By this we see that the dimensions of a 1 by n, so a row matrix with n elements, multiplied by a n by 1 column matrix will be 1 by 1, which we can think of as just a number. We'll use the multiplication of a row matrix by a column matrix to begin exploring how to actually calculate matrix multiplication. Here, a 1 by 2 multiplied by a 2 by 1 satisfies our check that it will be defined. The dimensions will be a 1 by 1, which we'll treat as a number. To actually calculate it, what we're going to do is we're going to multiply the first entries of both, and we'll add it to the product of the second two entries. This pattern is going to be the essence of our matrix multiplication. A 1 by 3 times a 3 by 1 matrix is defined, and the result will be a 1 by 1 matrix, or what we can think of as a number. To find it, let's multiply the first pair of entries, and add it to the product of the second pair of entries, which will also add the product of the third pair of entries. And we'll do one more example. For a 1 by 4 times a 4 by 1, we're going to start by multiplying the first pair of entries, adding the product of the second pair of entries, along with the second pair of entries, third pair of entries, and finally adding the last pair of entries. By understanding how we multiply a row matrix by a column matrix, we can define general matrix multiplication. The ijth entry of AB, which is to say the element that lives in the ith row and jth column of the product of the matrices A times B, is equal to the result of the ith row of A multiplied by the jth column of B. To help absorb this, let's look at an example. The element that lives in the first row and first column of the product will be the first row of the first matrix multiplied by the first column of the second matrix. And we might have to do that as a separate problem. 1, 2 times 6, 0 equals 1 times 6 plus 2 times 0, which equals 6. To identify what lives in the first row and second column, we'll take the elements that live in the first row and multiply by the things that live in the second column. We'll get 1 times 2 plus 2 times 1, which is 4. We'll look at the element. This position is row 2, column 1. So we'll look at the second row of the first column, the first column of the second. Which will produce 18. Finally, the last element we have to look at is the thing that lives in the second row and second column. So we'll be using the second row and the second column. 3, 4 times 2, 1 will be 3 times 2 plus 4 times 1 will equal 10. Let's do one more example. Let's do 1, 2, the 1 by 2 matrix, times the 2 by 3 matrix of 0, negative 1, 3, negative 2, 0, 4. This is a 1 by 2 times a 2 by 3. So the equality is defined. The result will be a 1 by 3. Our result, we're going to need to find 1, 2 times 0, negative 2. We'll need to know 1, 2 times negative 1, 0. And we'll need to know 1, 2 times 3, 4. Which should be 11. Consider the following information. Suppose we're given the table of 3 books, Lord of the Rings, Princess Bride, To Kill a Mockingbird, and we're given the amount of people surveyed that have read the book, and conversely, the people who have seen the corresponding movie. And suppose we're told that 20% of the people who have read the book own the book, and 5% of the people who have seen the movie own the movie. If you were asked for each intellectual property, how many people own either the book or movie? To answer this, for each IP, you could say, or you could multiply the number who have read it by 0.20 and add the number who watched it times the 0.05. However, this should look slightly familiar to our product of a row matrix times a column matrix. And here we can represent our table 100, 350, 125, 250, 200, 150, and multiply it by the matrix 0.20, 0.05. If we were to go through this process, the thing that lives in this first entry would correspond to the number of people that have read 300 or have read Lord of the Rings, so 100, times the percent of people who own a book after reading it, which is 0.2, and we would add the number of people who have watched Lord of the Rings, which is 350, multiplied by the 0.05, which is exactly how we would answer our question. Maybe we could use technology to get 37.5 for our first answer, 37.5 for our second answer, and 47.5 for our third answer. If we were asked for those who just owned the book, we'd have our same matrix 100, 350, 125, 250, 200, 150, and we would get, here we're only concerned about those that read the book. We're not going to count anyone from the movie section, and we would get 100 times 0.2 plus 350 times 0, which is 20, 125 times 0.2 plus 0 times 250, 25, and 200 times 0.2 plus 150 times 0, or 40. For the second one, I'll go back and interpret our answers. 20 people own Lord of the Rings as a book. 25 people own Princess Bride as a book. And 40 people own To Kill a Mockingbird as a book.